Okay, since it's been about 20 minutes and only one person has logged on and they haven't really asked any questions, I don't want to waste any more time. So I'm going to go over a few things that I think will be beneficial for you to know for your test tomorrow. All right, so first, just some basic test information. You are, and I'm going to go ahead and write in the meeting. Make sure you join Canvas conference so you can ask questions. Leave that up there at the top. Make sure you join Canvas conference so you can ask questions. So basically, a couple of things, just basic test information. It's 60 points, no calculator. 60 points, non-calc. And so it'd be 40 points calc, which is multiple choice and on Canvas. So 60 points is non-calculator, 40 points is calculator, multiple choice on Canvas. That being said, there are some of the questions have multiple parts, but there's 15 questions on the non-calculator portion and 10 questions on the calculator portion. So it's a rather small test. And it covers basically everything from chapter 6. It's heavier on solving. Finding the inverse, and graphing. It's heavier on those topics, but it does have some simplifying topics from the part 1 exam, such as, negative exponents, fractions as exponents, simplifying radicals, all of that kind of information. One thing that turns up on the test that I want to make sure that we are familiar with is it's something that happened. It was a couple chapters ago. A couple of you are actually upset that we didn't do it, but it was like f composed of g of x. And that actually makes a reappearance on this test. And so I want to do a couple problems like that. And so until someone logs onto the conference and asks me a question, I'm just going to go ahead and do a couple examples of that. So let's say I have f of x equals x plus 3 and g of x equals x squared minus 1. What you might get on the test is, say, g composed of f of negative 2. So what that means is you are going to take negative 2 and plug it into the f function, and then take that answer and plug it into the g function. So for this example we have up here, we would say negative 2 plus 3 equals 1, and then we would take that 1 and plug it in for x there. And so we would get 1 squared minus 1. 1 minus 1 equals 0. So g composed of f of negative 2 would be 0. You will be expected to do that type of problem. And so let's say f of x is x plus 3, g of x is x squared minus 1, and I want to know g of f of negative 2. What that means is I'm going to take negative 2, plug it in for f, take that answer, plug it into g. So I took negative 2, plugged it in for x up here, negative 2 plus 3 equals 1, took that answer and plugged it into x over here. 1 squared minus 1. 1 minus 1 is 0. So g composed of f of negative 2 equals 0. Still nobody on the conference, so I don't think people are doing a very good job of reading instructions, but that's okay. I'll just keep pressing on. Let me do another one. So let's say f of x equals x squared plus 3, and g of x equals x minus 1. And let's say I want to know what g composed of f of negative 1 would be. So that means I'm going to take negative 1, plug it in for f, see what the answer is, and then plug it into my g function. And so let's just go ahead and do that. Negative 1 squared plus 3 will give me 1 plus 3, which is 4. So I'm now going to take that 4, which is my answer of f of negative 1, and I'm going to plug it in to my g of x function. And so I get 4 minus 1, which is 3. And so my answer g of f of negative 1 would be 3. Now we're going to make it just one step harder. I'm going to use the same two functions I just had. So I'm going to stick with f of x equals x squared plus 3. And I'm going to stick with g of x equals x minus 1. But this time, I'm going to do f of, I want you to pay real close attention, f composed of the inverse of f of 2. So first, this is combining quite a few skills. So first I have to find the inverse of this function, which remember to do that, we're just going to flip x and y and then solve for y. So x equals y squared plus 3. I subtract 3 from each side. I get x minus 3 equals y squared. I screwed each side. I get y equals plus or minus x minus 3. And so now that I have the inverse, I can change this y back to an f of negative 1. Of x. And so now I'm going to take 2 and I'm going to plug it into here. And so I get square root of 2 minus 3. Let me pick a different number here, that way we can actually get an answer. Let's say it's 4. And so I'm going to plug in 4 into my equation. Because see, that would have been imaginary and that would have been very good. So the square root of 4 minus 3 is the square root of 1. So I got plus or minus 1 as my answer. So I'm going to have two answers, plus and minus 1, and I need to plug that into my original function of x. Well, the cool thing is regardless, 1 squared plus 3 will equal 4. Negative 1 squared plus 3 will equal 4. So either way, my answer to that question is 4. And so that is a type of problem you may have to do that's pretty difficult. Let me see if there's anybody in the conference yet. Still nobody in the conference. That's pretty frustrating because you clearly just aren't reading instructions. So let me go back to the very first page so they can see this. Make sure you join the Canvas conference so you can ask questions. I'm going to underline that in red so maybe the people who are seeing it can, figure it out. Make sure that you're joining the Canvas conference so you can ask questions. I'm not going to feel bad for you guys if you're not paying attention to instructions. Just for those who are watching the video later on, I want to show you something. Look at this. Module 6 review. The instructions are pretty clear. The meet is this number, which at this point in time, 6 people are logged into. And then it says, join the meeting and then click the link below to access the Canvas conference. You can ask me questions on there and then I will answer them in the meeting. I will stay on for about an hour. Here's the conference. Nobody's on. I'm sitting here waiting for people to get on and ask me questions, but no one's really doing it. So I'll just keep doing practice problems. And so that function composition, that's going to be a big part of it. We've done it before. It's just been a while, and we've come back to it. There is, and I expect if you don't understand it for you to come in and see me tomorrow, but there is 1, 2, I think there are 3 questions on the exam that are G of F or F of G function composition. The other big thing is solving radicals. Solving radicals. You need to be able to do this. And there are a basic set of steps that you need to be able to do. And basically, you need to isolate the radical. It could also be an exponent. You need to isolate it, which means you need to get it by itself. That's step 1. Oops. Then, after you have it isolated, you need to basically take the inverse, which means get rid of the radical or the exponent. Meaning, if I have a square root symbol, I'm going to square each side because that gets rid of the square root symbol. Or if I have a cube, I'm going to take the cube root of each side because that gets rid of that power of 3. Once you have isolated the radical, taken the inverse to get rid of the radical or exponent, then you're just going to do math, do algebra. So you're going to solve for x. Remember that if it's quadratic, you need to set the sides, get all of your variables on one side and set it equal to 0, and that way you can factor and set your factors equal to 0 and solve. And then once you do algebra, you need to check for extraneous solutions. So plug it back in and check for extraneous solutions. Those are the basic 4 steps when you are solving a radical. The only weird little hitch you might have is if you have 2 radicals, you want to separate them. And you do the equal sign to separate them. So I'll show you an example of that. So let's just take one of the problems from the review packet. Maybe number 41 on the review packet. We have the square root of x plus 20 equals x. Well, step 1, isolate the radical. Well, you can see the radical is right here and it's already by itself. We don't need to do anything to it. It's already isolated. So what we need to do is now take the inverse to get rid of the radical. Well, to get rid of that radical, I will square each side. So I'm going to square each side. And when I do that, the square root symbol and the power of 2 basically cancel each other out, and I'm left with x plus 20 equals x squared. Now I need to do algebra. Remember, when you have a quadratic, you want to set everything equal on one side to 0. So I'm going to subtract x and subtract 20 from each side. The reason I do that is I don't want to deal with negative x squared. I would rather deal with negative x and negative 20. So now I need to factor this. What multiplies to give me negative 20 and adds to give me negative 1? X plus 5 and x plus 4 and x minus 5. 4 times negative 5 is negative 20, and 4 plus negative 5 is negative 1. And so now I can set each of my factors equal to 0 and see that x will equal negative 4 and x will equal 5. And so now that x equals negative 4 and x equals negative 5, the only step I have to do is check for extraneous solutions. So if I plug negative 4 back into here, I'll use green to check negative 4. The square root of negative 4 plus 20, does that equal negative 4? Well, the square root of negative 4 plus 20 is square root of 16. Does that equal negative 4? 4 does not equal negative 4. So it is extraneous. Let's check the 5. Does the square root of 5 plus 20 equal 5? Square root of 25 equal 5. 5 does equal 5. So the solution to the problem is x equals 5. So that is how you do it. Let's move on to another problem where we have to separate our radicals with the equal sign. So this is where we're going to look at something, and we did this in class, but I'll do it again, something like this. Square root of 10x minus 2 times the square root of 5x minus 25 equals 0. Well, the first thing we have to do is isolate the radical. Well, we have two radicals here, so we need to separate them. The best way to do that is to put this one on the other side, because now they're both isolated. We have separated them. Now, the second step, if you recall, was to take the inverse to get these radicals to cancel out. Well, the cool thing is both of these we just have to square, so that helps us out. That leaves me with 10x equals, well, 2 squared is 4, and the 5x minus 25 squared cancels out, leaving me with just 5x minus 25. Now I need to do math. I'll distribute here. 10x equals 20x minus 100. And then I've got to get my x's on one side. Negative 10x equals negative 100. Sorry, there's a little bit of lag in the computer here. Wait for it to catch up. There we go. And then I divide each side by negative 10. X equals 10. Now, the very last step is to plug that in and make sure there's not an extraneous solution. All right, so that's what I got, and I need that to be equal to 0. Well, 10 times 10 is 100, and the square root of 100 is 10. 5 times 10 is 50. 50 minus 25 is 25. The square root of 25 is 5. 5 times 2 is 10. 10 minus 10 is 0. Does 0 equal 0? Well, it absolutely does. And so we know that this answer is correct. All right, this is a perfect time. I'm going to check the conference. Still nobody in the conference. I'm going to go ahead and quit the conference real quick and rejoin to make sure nothing's going on here. Just to be safe, because maybe there's a bunch of people in there asking questions and I'm just messing it up.
You are currently the only person in this conference.
Yeah, I'm currently the only person in the conference, so that is not good. But, you know, what can you do? I mean, I can't do everything for you guys, so if someone ends up figuring out and logging on and asks a question, great. If not, send me a Canvas message. I'll probably be up for a little while, but I'll just keep on doing some review questions. Go back to the board here. All right, so solving is a big portion of it. Doing that function operation is a pretty big part of it. Then it's just, the simplification process. You guys have been doing pretty well with that, so I'm not going to spend a whole lot of time on it. We've covered inverse function just a few moments ago. I'm going to cover graphing here in a couple minutes. I think it's going to be great. I think you guys are going to be fine. So let's talk about graphing. Again, remember, there are two types that I'll ask you to graph, a square root and a cube root. And I think the best strategy is to memorize what these parent graphs look like. I pick 0, 1, 4, and 9 because those are all perfect squares. That will give me 0, 1, 2, 3. And then I pick -8, -1, 0, 1, 8 because those are all perfect cubes. You can pick whatever you want, but without a calculator, those are just the easiest to do. And so now I just have to remember my rules. So I'm just going to write one general rule here. Y equals negative a, and then we have some radical x minus h plus k. And your general rules are that the negative symbol reflects over x. The a value, you're going to times that or multiply it by your y. Because that stretches, multiply your y values. Because that stretches or shrinks your graph. Your h value is going to be left and right movements and its opposite. Your k values are going to be up and down movements and they are not opposite. And so all that means is if you have a negative number, you're going to change all your signs on your y value. So 0 wouldn't change, 1 would be -1, 2 would be -2, 3 would be -3. Or if it was a cube root, -2 would become 2, -1 would become 1, 0 would stay 0, 1 would become -1, and 2 would become -2. If you have an a value, so a number here, you're just going to multiply all your y values in your table by that number. And you always multiply first. If you have a k value, you're just going to add that or subtract that to all your y values in the table. The only thing that you do to your x is if you have something under the radical. Then you do the opposite. So if it's minus h, you're going to add that number to all of your x values. If it's plus h, then you're going to subtract that number from all of your x values. So let's do two examples on the next slide. Let's do y equals 2 square root of x minus 1 plus 1. And let's do y equals, we'll just make it real easy, negative cube root of x plus 2. All right, so let me draw a graph here. There's my graphs. All right, so in this first one, it's a square root function. And so I'm going to remember my square root table. 0, 1, 4, 9, 0, 1, 2, 3. That's my parent function for my square root. I'm going to take my x values and I'm going to add 1 to all of them because that -1 means they all go to the right. So it becomes 1, 2, 5, and 10. My y values, I'm going to multiply them by 2 and then add 1. So 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And 3 times 2 is 6, plus 1 is 7. So now I have my new points. I have 1, 1. I have 2, 3. I have 5, 5. and I have 10, 7. And recall that the parent radical function looks like this: 0, 0, 1, 1, 4, 2, and 9, 3. So that's what the parent function looked like. So you can see it has moved to the right one, up 1, and it is stretched by a factor of 2. Pretty crazy, right? So now I look at the cube root function and recall that I have this as a parent function. Actually, let's put it over here. -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. That is my parent function of my cube root. And all that's going to change with it is I'm going to change the signs on all my y values and subtract 2 from all my x values. Let's do this one in green. So I'm going to subtract 2 from all my x values. -8 minus 2 is -10. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. And 8 minus 2 is 6. My y values, I'm just going to change the signs. So it was -2. It's now going to be +2. It was -1. Now it's +1. 0 doesn't change. It was +1. Now it's -1. It was +2. Now it's -2. And I plot those points. So I have -10, +2. I have -3, +1. I have 0, -2. I have, I'm sorry, plotted that wrong. It's -2, 0. -2, 0, which is right there. Then it's -1, -1. And then it's 6, -2. So it looks something like that. And recall that the parent function of the cube was -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So that's the parent function. You'll notice it didn't stretch or shrink, but it did flip. So all the points that were up down here flipped over the x-axis up there, and all the points that were up here flipped over the x-axis down there. That's because of that negative symbol. And then I took my axis and I moved to the left 2 because it's +2 under the radical. So that is graphing in a nutshell. Still nobody in the conference. Fantastic. Okay, so I've covered graphing, I've covered solving. Really, I just encourage you to double check your exponent rules. You know, the only thing I want to show you on the very last part, you won't be able to see in the meeting, you'll actually have to watch the video, but it's a little trick that you can do on your calculator to check your work to make sure you're doing things correctly on the calculator portion of the exam. It's a pretty cool little trick. So let's say I did oh goodness, I don't know. Let's just say x squared y to the 1/2, all of that to the -2 power. All right, without a calculator, what I would expect you to do, because this is multiplication, I would expect you to multiply these exponents to get x to the -4 times y to the -1. And then I would expect you to see that because they're both negative, you would put them on the bottom of a fraction, x to the 4th, y to the 1st. And so you might be wondering, is there a way to check your answer? Well, the best way to do this, if you're watching the video, is the stow feature on your calculator. And here's what the stow feature allows you to do. I'm going to pull up my graphing calculator here. So what this allows you to do is I'm going to store a value for x and a value for y. I highly recommend not using 0 or 1. I use 2 and 3 always. So you're going to hit 2, then the stow button, which is right here, STO, and then x, alpha x, enter. So now x is 2. You can see if I just put x in, it'll say 2. Or if I do 3x, well, if x is 2, 3 times 2 should be 6. And sure enough, it's 6. I'm going to do the same thing for y. 3, stow, alpha, y. So now I've stored 3 for y. And so now what I want to do, if I simplified this correctly, if I plug this expression into the calculator and this expression into the calculator, they should be the same value. So let's try it. Parenthesis, x squared times alpha y to the parentheses 1/2 power, that whole thing to the -2 power. So you can see I get 0.02083 repeating. This answer should be the same thing. Let's try it. 1 divided by parentheses x to the 4th y. Look at that, exact same answer. So that's how you know that you can check on the calculator portion if you've done your simplifying right, even if there's an x and a y in there. And so I'll show this in the review session tomorrow morning, but this is a trick of the trade that I usually don't teach until closer to EOC time, but this is a benefit given to those who actually came to the review session or watch this video. So now that x and y are stowed, I've stored them, I can do any equation that has x and y in it. I can check my work to make sure I did it correctly. Pretty cool feature. And so that's how I know that this is correct. So, basically this video is going to be concluded. It's about an hour long. No one ever ended up joining the conference, so we'll have to talk about how to do this. It was a trial run. I just thought this would be the best way for people to tune into the live lecture, as well as me be able to record it for people to watch later, and have this conference open for people to ask questions. But maybe I should have went over a little better. So just on this last slide, I'm just going to write a little note. And it's going to say, this concludes session. A link to the video will be available momentarily. Please export the notes from this meeting. If you have questions, please canvass me or come see me in the morning. All right, so hopefully everybody sees this message, and I can see the maximum participants we ever had was 6, and those people usually like to ask questions, but I don't think they read the directions well enough. So until next time, otherwise I expect to see you guys tomorrow morning. That'll be all. Goodbye.